Hello everyone, this is Preeti Rana from CSC department. Today I am going to discuss another important topic related to your computer network subject. Usually many questions is there in different interview. So I think this is one of the most important topics. So please try to understand this topic carefully, okay? So let's begin the topic, that is the topology. Now what is topology? Topology is the way in which all the nodes are connected in the network. This topology is a kind of arrangement under which the different nodes that is there on the networks are connected to under the network. So topology is mainly of two types, network topology and physical topology. What is network topology? Network topology is the way or the arrangement in which the different elements of the network, it can be node, it can be the link that is used to connect the two nodes, okay? So how these different elements are connected, are arranged in the network, that is defined by network topology. And the other one is physical topology. What is physical topology? Physical topology describes the actual position, the particular location, the particular position on which the nodes are there, that is to be connected over the network. That is physical topology. So I hope this is clear to you. What is network topology? What is physical topology? And what is topology? Topology is the way, arrangement of different elements over the networks by which they are going to communicate with each other. As you can see in different diagrams. Now I am going to explain the different types of topology. These are as follows: star, bus, ring, tree topology, and mesh topology. I'm going to explain these topologies one by one, its drawback, its advantages, the reason why we consider one topology over the another. So the first topology I'm going to discuss is star topology. What is star topology? As you can see in the diagram, there is one single server, the mainframe computer, and all the other computers are client. This is the way, this is the arrangement through which the different nodes are connected to each other. The server computer is the mainframe computer, is the main workstation through which different clients communicate over the network. All the information that is required is stored in the server only, okay? So server is the main computer, that is a very important computer in terms of star topology. So as you can see, for every n nodes, okay, on a network, if you have n nodes, how many links has to be used? n-1. Okay, for every n nodes, the number of links that is required over the network to connect these different nodes are n-1. Okay, like as you can see, you have 5 clients and 1 server. So number of workstations are 6. But how many links are there? 5 n-1. 6 minus 1, that is 5 links has to be there to connect a single server to different clients. One most important thing is, whenever, as you can see, if you need to connect one or more devices to this network, like you want to add one more client, okay? You want to add one more client to this mainframe computer for communication. You just need to set up a link that is there in between server and client. No another installation cost, no other maintenance cost is required. Just a little bit of the installation cost for connecting these two devices is there for connecting a single client to the main communication network. So in terms of installation cost, this is very simple technique. You just need the basic installation cost for connecting the two devices over the main network. Again, fault isolation is very simple. How the fault isolation is simple? You understand the meaning of fault isolation? Isolation means to isolate something, okay? To isolate something to a small area. So here fault isolation is very simple. Why? Because if some client is, is not there to communicate with the server, or if some client, some communication is not there between the server and some particular client, that means that particular link is damaged. So the fault is isolated to a particular link. So fault isolation is very simple in the case of star network. The installation cost is very simple. Fault isolation is very simple. Maintenance is very simple. But the main drawback, as you can see, there is only one server computer, one mainframe computer that is used to store all the data that is communicating over the network. So if one server fails, all the network fails. This is very simple. You can even consider, you can, observe this by yourself. If one server fails, all the network fails. So this is the main drawback with star network. Okay. So let's switch over to the other topology, that is ring topology. I hope this concept is clear to you all, the star topology. The next is ring topology. Now what is ring topology? As you can see, all the workstations, all the computers that is used to communicate over the network, a single dedicated link, a single link is connected, is used to connect the different workstations over the network, and that single link is called as ring. Like you can see, all the devices are connected in the form of link, in the form of ring. Okay, so whenever a workstation needs to communicate with other workstation, the single ring is used to communicate. Here we have two things. This ring can be unidirectional and this ring can be bidirectional. Now what is unidirectional? Uni means one, right? You are right. Unidirectional is one. So in the case of unidirectional, a single link is used to communicate over the network. So again, you can observe this by yourself, that if some failure occurs, if that ring fails, that is a unidirectional ring, then whole network, comes to a deadlock state. There is no way to communicate over these workstations. So usually with ring topology, what we do is, when we need to set up a unidirectional ring topology, we usually use a software, a backup software that is called as a backup software. So if this ring fails or if particular workstation fails, this particular backup server is used to communicate over the network. Again, this is unidirectional, but we can use bidirectional ring also. Now, what is bidirectional? You can, two ways are there to communicate from source to destination. Either source to destination and or from destination to source. Like you want a communication setup between workstation 1 and workstation 2. So what you are going to do is, if you are using unidirectional, a single link is used. But when you are using bidirectional, the data can be transferred from either side, from workstation 1 to workstation 2, and you can even use the other bidirectional ring to send the data from either side. So here, if one ring fails, the communication continues. So this is ring topology. In ring topology, I have already explained you that if any workstation, particular workstation fails, then the backup server is used. This is the major drawback, that you have to install a backup server for this ring topology. So maintenance cost, installation cost is heavy. Another drawback is, a delay is there. Like you need to transmit a data from workstation 1 to workstation 6. Okay, so the data will first transmitted to the workstation 2. So some delay is there. Delay is there at workstation 2, right? Then the data is transmitted from server 2 to workstation 3. So some delay is again there at workstation 3. Then the data is transmitted to the workstation 6. So 2 times the delay exists or comes while communicating from workstation 1 to workstation 2. So the data rate at which the data is transmitting from workstation 1, to workstation 6 is little higher because the delay is there in ring topology. So this is the another ring topology that we usually prefers over the network. We have the remaining topologies that we need to discuss is tree topology, bus topology, and mesh topology. Now, what is tree topology? In tree topology, this is basically a topology in which the nodes are connected in a hierarchical fashion and allows the communication to flow through the branches. Like we have the nodes that are connected at different levels, and the nodes at the lowest level is controlled by the nodes at the highest level. Like this is the mainframe node. This is the mainframe computer that is going to control all the information that flows along the network. This is PC1, this is PC2, PC3, 4, 5, 6 and 7. So if you want to add some node on particular level, then simply the node is connected at the lowest level at the end of the communicating node. So it is very simple to add a particular node or delete a particular node over this kind of topology. This is a very simple topology. So a simple software is used to connect this kind of topology, and installation and maintenance cost is very less. Then in bus topology, a single communication link is used to connect all the devices over the network. So all the computers that are connected over the bus topology have a particular address through which that particular node is identified by the user that needs to communicate through the network. Like PC1 wants to send the data to the PC4. So a single communication link is used. What is going to do is, every time the data reaches a particular node, checks the IP address, checks the physical address of that particular node. If that matches, then that data is transmitted to that particular node. Otherwise, the data is forwarded to the another node. So this is a technique in which the user just need to check the destination address by which they can communicate over the network. So this is bus topology. The biggest drawback of bus topology is, if this communication link fails, then the entire communication setup is fail. It goes to the deadlock state. Then next is mesh topology. Mesh topology, every device is connected to every other device over the network. So the installation cost, the maintenance cost is very high, because for every 2 nodes, the possible number of connecting links are 2. Okay. So for n number of nodes, the n number of communication links are set up between those particular nodes. So this mesh topology is very useful in the case of sending a data that is to be secure, because if some particular link fails to send the data over 2 endpoints, then the other communication link can be used to send the data over the network. This is mesh topology. So these are one of the different topologies that we use over the network. If you like my video, please like and subscribe RPIIT channel. Thank you.